Hello, everyone. We are going to start in a few seconds. So, my name is Jean Villedieu. I'm one of the co-founders of Linkurious. Today, I will be talking about a particular topic, data lineage, and how it applies in finance. So this is a complex topic, and we have 30 minutes. What I'm going to try to accomplish today is explain to you what is data lineage, and also explain what you can expect in terms of benefits from using graph technologies to solve your data lineage challenges. So first, a quick word of introduction. My company, Linkurious, specializes in helping organizations extract insights from graph data. We have products which are used by customers like NASA, Zurich Insurance, or the French Ministry of Finances in various domains, including anti-money laundering, cybersecurity, or medical research. For today's topic, I will be first explaining to you what is data lineage. Then I will also explain why it's so important right now in finance. I will also compare and contrast two approaches to data lineage. First, the relational-based approach to data lineage. And after that, I will explain what you can expect from using graph technologies to address your data lineage challenges. After that, I will give you a demo based on Neo4j and Linkurious on how to accomplish some data lineage investigations. And I will also discuss how to use Linkurious to accomplish that. And finally, share with you a case study from a concrete customer. So this is today's agenda. So first, what is data lineage? Who here is familiar with data lineage? Please raise your hands. Okay. So data lineage is the exploration, the analysis of the data's life cycle from where it originates to where it flows through time. It's also the analysis of the various data points as they move from processes. So this is what data lineage is. Said like that, it may sound a bit abstract, but data lineage is very necessary for common questions. Questions like, where is this particular data point originating from? Or what would be the impact of me removing or changing a process in my data pipeline? Or another question like, is a particularly sensitive data point, a particularly sensitive information, is being propagated across my organization in unsafe manner? So for all of these questions, to answer these questions, we need to establish strong data lineage to be able to provide concrete data-oriented answers. So this is what data lineage is. So accomplishing good data lineage supposes two things. First, you need to get an understanding of things like the various data systems that you have, data stores, DBs, data warehouses, but also be able to understand the metadata associated with your data, or even the various applications that you manage. And if you want to have very fine-grained data lineage, the individual data points. But it's not just about getting an understanding of these individual entities. What's just as important as these entities are the relationships in your data. We are talking about lineage, about the flow of data, so it's very important to understand how these various information are interconnected and form a larger graph, a data lineage graph. The thing is, in that big organizations with many processes, many complex reports, very quickly data lineage can escalate and become quite complex. Here on the right, you can see a topic which gives you an idea of what it means in real life to establish data lineage and try to untangle the complex connections in a real life enterprise architecture. So it's no surprise that a lot of companies, a lot of organizations are struggling right now to establish strong data lineage capabilities. But why focus on data lineage? There are some reasons, generic across all industries. It could be, for example, to create a new data pipeline and create new data products. Perhaps you want to understand deeply what sort of data assets that you have to be able to maintain them and to change them. It could be also your enterprise architecture group who wants to be able to track data lineage, to manage change and establish good practices around that. But in our experience, this sort of use cases oftentimes don't remain a top priority for companies for a long time. And we see a lot of projects losing momentum and these capabilities moving away. But things are different in finance. Who here has heard about BCBS 239? Okay. CCAR. Okay. The same folks, I guess. And GDPR. Okay. So these are new legal frameworks, the result of a more active surveillance of the financial actors by the various regulatory instances. So in the US, it's the SEC. In the UK, it's the Financial Conduct Authority. In France, it could be the AMF. These authorities are imposing a series of regulations and rules that financial organizations have to obey by. So, for example, BCBS 239 is all about the reporting of risk. You report some information to the regulators about your risk exposure, and you need to be very detailed and fine-grained about all these metrics were computed. CCAR, which concerns very large banks in the US, is about the capital requirements. And once again, reporting information about that means being able to have a high degree of confidence about the data that you provide to the regulatory instances. Finally, GDPR is something coming from that thing called the EU, which is still relevant to today at least, and it's about the protection of individual data and of the data belonging to citizens. So all of these regulations apply to financial institutions to different degree and constitute a big pressure on them in terms of compliance. Not respecting these rules, these laws, means for financial institutions potential big fines. So here it creates a lot of momentum and a big pressure on organizations to finally take data lineage in a very serious fashion. So that's why we are seeing a lot of banks, insurance companies, money transfer companies investing more and more in data lineage. And some of them start with known technologies, known tools, rational oriented technologies. Think relational databases. But the problem with that aspect is that in relational databases, you are thinking in terms of tables. This is very well suited when your data is a set of similar entities. Think, for example, a metadata glossary or a list of systems in your CMDB. But it's much more difficult to model complex networks, the complex networks associated with data lineage, because you have a lot of interconnections between the various entities. Modeling that in a racial schema is quite painful, and it's also very difficult to adapt the schema as the business needs evolve. As you add new systems, new processes, it's very hard to keep track of what is going on and to avoid complex re-engineering of your schema. So really ends up in practice is that the data becomes isolated in different silos. You have some information about the metadata on one side and other things on another. And it's very, I mean, you have a hard time getting an overall picture of how things are interconnected, which is necessary for data lineage. So you have stale data, which requires a lot of consolidation to be able to understand how things are interconnected, which means in practice long and complex investigations, which results in slow answers, inability to reply fast to business requirements, and potentially legal exposure. So that's what we are seeing with companies, organizations choosing a rational-based approach to data lineage. It comes with a lot of challenges and struggles. But there's another way which revolves around using graph technologies to address the data lineage challenge. And with a graph approach, it's much more natural. It's much more natural because the data is modeled as a set of nodes and edges, and it's a very flexible way to represent your data lineage. So what that brings is the ability to not only model your data lineage, but also to adapt to the continuous evolution of this data lineage within your organization. Another big thing is that with graph databases, you have the ability to run with great performances, deep queries with lots of relationships, without having to pay the price of joins every time you traverse up on the network. So if you are interested in the shortest path between point A and point B, graph databases can get you an answer in very fast. The result of all that is quite transformative. With graph technologies, you have a strong foundation to create a data lineage graph where you can keep up to date the data lineage information within your organization and query it with great performances. So this brings more clarity into what is going on, faster answers, and less smaller legal risk. So now at this point, I would like to give you a demo that we have prepared with a partner, Data to Value. For this demo, we are going to focus on something specific. We are going to explore the flow of metadata through processes, reports, but also through various systems. So we are going to be using some data that we have prepared with Data to Value, which is being stored in Neo4j, and we are going to access that via the Linkurious Enterprise interface. So first, I'm going to start Linkurious Enterprise. Invoke the demo gods. So this is the interface of Linkurious Enterprise. Right now, we are connected to one Neo4j database, and we are going to be exploring it. So first task that we are going to accomplish is investigate where where the data associated with a particular report is coming from. What systems, what processes are originating, have been used to generate that report. So I'm going to go ahead and type the name of the report. I want to know about sales about the monthly sales report per channel. So this is a report within my organization. I'm looking it up. I can see that report popping up right there. So this is one node within a larger graph. I can see on the left that this is indeed a report. It has a name, which is the monthly sales report per channel. More interestingly, right now is the little number 3 next to the node. So this represents the number of undisclosed connections associated with the report. I'm going to double click, and we are going to pull data out of Neo4j. So we can see some new nodes popping up on the screen. So we can see that the monthly sales report as a used in relationship, with something called the sales results review. So that would be a process, an internal process within the company. The monthly sales report is also associated with one column called full name and another column called channel. So these columns, think columns within databases. Okay. So this full name column is associated with 7 other elements. I want to know where these 7 elements are originating from. So I'm going to double click. So we can see some information popping up. We can see that we have a name column. So the full name is flowing to the name column, but the first name is flowing into the full name column. We can see that the full name is flowing to the salutation, but is elemented by the salutation column, and so on and so on. We can also see that the full name is actually stored in the data warehouse.customer table. So we have, that data warehouse customer table, which stores the full name, which is exposed in the monthly sales report per channel. So that's one part of the story. Right now I'm going to look into the channel column associated with the monthly sales reports. I'm going to double click on that. And we see some new information popping up. Okay, so we can see that this channel column is stored in another data warehouse. So we have 2 different data warehouses right now involved in the preparation of that report. We can see that the channel column is flowing from the sales channel column, and both are aligned with the same sales channel data element. So perhaps I want to know more about the sales channel, so I'm going to go ahead and double click. And we can see that this column is actually originating from the CRM, the CRM, and more specifically from a table within that CRM. And I can keep on drilling down in the data. We can see that the CRM.opportunity table is actually stored in the CRM DB. Okay, going back for a second now to the full name column, we have seen that it's associated with a number of other columns, and perhaps I may want to expand a little bit about that and learn more about where this column is coming from. So I'm going to double click on the full name, and what happens right now is that we can see that we have first data element, which is right there, connected to multiple nodes, connected to the salutation node, to the middle name node, to the last name node, but also to the first name node. We can see that we have another type of node, a data quality metric. You can see that here, associated with the salutation, with the first name, with the last name, and with the middle name. And we can see that these columns that we have uncovered are actually stored in the CRM.customer table, which itself is stored in the CRM.db database. Okay, so what we have done is that we have started with one particular report, and we've been exploring dynamically, asking questions via the Linkurious interface to uncover what processes, what metadata was associated with that report. And we've been able to track down, for example, a data warehouse, which is right there, and a CRM DB. So we have, we have a better understanding of the data lineage associated with that report. At this point, I may want, to save the results of this investigation. Okay. If I want to, I can, save. I can share the visualization with a colleague. Let's say I'm working with John and I want to communicate the results that we have just uncovered. I can add him to the document so that he will be able to see that visualization that we have created. You can also export the visualization to Excel, PNG, SVG to facilitate the communication of the data and insights. Now I'm going back to the menu, and we are going to see another scenario. This time we want to uncover some patterns in our data, and we are going to use some alerts for that. So I'm going to click on the alerts. Okay. And we want to uncover data elements that are replicated across various databases. So to uncover that, we have prepared a Cypher query. So we can see that it starts with a match. We try to identify data elements connected to multiple databases. And then we choose to return only data elements that are associated with more than one database. So we want to uncover some duplication. Okay, so this is something that can be typically set up by an analyst or data scientist. And then as an analyst, I can review the results of that query. Here I can see that I have just one single result, and I can visualize it. So we have just one single data element, the sales office data element, which is stored both in a data warehouse, yeah, and in a CRM DB. So with these alerts, you have the ability to really streamline the monitoring of your graph data and facilitate the discovery of insights hidden in these massive graphs. So here we see the data element. It's stored in this column, the SLS office column, but also in this sales office column. And we can see that this column is associated with a table, crm.opportunity, which is stored on the CRM database, whereas this column is stored in a table called data warehouse.sales, which itself belongs to the data warehouse database. Okay. I'm going to exit. So we have seen how to accomplish some data lineage investigations with Linkurious. Right now I'm going to go back to my presentation. And I will talk a little bit about how that demo was built. So the Linkurious Enterprise software is something that is directly compatible with Neo4j. So you can install that on your infrastructure, Linux, Windows, or Mac. You can connect it to Neo4j. So that would be your Neo4j graph database. You are free to ingest data in Neo4j from any sources. Think flat files to Oracle databases and so on. And then you can access that data in a secure fashion via the Linkurious Enterprise Web UI. So we support authentication with LDAP and Active Directory, for example, but also access rights management. And for clients who want to integrate the sort of capabilities that we have seen in their own applications or build new applications, you can use the Linkurious Enterprise API and the Linkurious JavaScript library to build custom interfaces. So this setup really makes it easier to curate your data. You can modify the graph, add nodes, add relationships to the graph. You can also monitor the graph for specific graph patterns that you can set up. And it makes these capabilities accessible not just to developers, but to any type of user with minimal training. Okay. Now I will mention one specific use case. So this is work that we have done with a bank in Europe. They were struggling with data lineage, and each quarter when they had to report metrics, they had a complex set of processes and a lot of data sources to consolidate, to be able to finally communicate some figures, some numbers to the regulator. So it was, every quarter it was crisis time. Basically, they were all, working on that, doing complex investigations, doing back and forth between the people in charge of the reporting and the technical team in charge of getting the data together. It was frustrating for them because they were investing a lot of time in doing that, and they were not very confident about what sort of metrics they were reporting. So what they have done is that they have progressively moved their data to Neo4j, so ingesting data from various sources and building a data lineage graph. The data lineage graph is accessible via the Linkurious Enterprise web UI. So that means that it's not just the developers, the software architects that can access the data, but any IT analyst, any business people for that matters, can directly ask questions and find answers in the data via the Linkurious Enterprise web UI. So the result of that is that it's way more easier for them to investigate the data and to understand exactly the data lineage associated with reports. They can also accomplish some change management. If they are thinking about modifying, metadata, they can see what it is associated with. They can think about what would be the impact of modifying that, and also communicate this impact in a visual fashion via the Linkurious web UI. Okay. And in the end, it has allowed them a lot more flexibility in the way they are handling data lineage, and more agility. So that's it for today's presentation. We have a booth outside. If you have any questions, if you want to take this conversation further, feel free to visit us. Thank you very much.